Hello everyone. I wanted to go over what you need to know for our next quiz. These are things that we've covered, but I just want to make sure that you understand how I'm getting the answers to this worksheet. So if you have questions, I've got some links to videos, or ask me or ask a friend. So let's talk about valence electrons. Valence electrons on the outside, and they're important because when atoms collide, when they react, that's the first thing that touches is the outside. So how many they have and how easily they're lost or gained, that is going to depend on how reactive they are and what they react with. Okay, how do I know the valence electrons in an atom? It's the group number. Group number, I mean these. Now that's a group number too, but we're not going to use this system. That's the international system. We are going to use the A's or B's. Okay, so when I talk about group number, it's this. For example, this would have 5 valence electrons. This one would have 1. This one would have 6. So go by the group number. And these down at the very bottom, we're going to ignore those for now. Okay, so if I have this question, which has 1 valence electron, well, 1A, the alkali metals, which are these, not hydrogen, these. I would have 1B, which are these, not the bottom. Okay, so these, not the bottom ones. And then hydrogen is in a group by itself, so it's also in 1A. So it'd be hydrogen, it would be the alkali metals, and it would be group 1B. Okay, how about the ones that have 3 valence electrons? Well, those are going to be 3B and 3A, all of these. Okay, so which has 5 valence electrons? We look for fluorine. Fluorine is right here. It has 7. I look for arsenic. It is 5. And I look for calcium. Calcium has 2. So which has 5? It would be this one. On the quiz, I will not have these same elements. I will have different ones. But if you understand how to do this, you will get it. Okay, metalloids are along the stair-step line. So notice the ones that we colored in. You can use your colored in periodic table. Notice that everything that touches the stair-step line except aluminum. Aluminum is a metal. Okay, which of these is a metalloid? So I'm going to look and see. And arsenic, we had looked at it before. It is definitely a metalloid. It touches on that stair-step line. Okay, metals are located left and down. So if we disregard the metalloids for now, just see if it's a metal or non-metal. Everything to the left and down of the stair-step line, those are metals. Everything in this corner right here, all these are non-metals. So which one is a metal? Well, we're going to take a look. Chlorine is right here. It's a non-metal. Sodium right here is definitely a metal. And let's just check carbon. Carbon is on this little corner, so it is a non-metal. Okay, metals tend to lose electrons. You just need to know that one. Non-metals gain, metals lose. And they're going to lose all of their valence electrons. So which one will lose? Well, I'm going to look at fluorine. No, it'll gain. Arsenic, it could do either. And then I've got sodium right here, and it is definitely a metal, and it is going to lose. How many? Well, it goes by the group number. So sodium would lose 1 electron. Okay, so, sorry, on the wrong one. Which one of these will lose? That's going to be calcium. Same thing. Calcium is over on the metal side, the left side, so it is going to lose. It's in group 2, so it will lose 2. Okay, how many valence electrons will aluminum lose? Find aluminum. Look up at the top. 3A. So it has 3, and it will lose those 3. so it will lose 3. Nonmetals, on the other hand, all this little corner, they want to have 8 valence electrons. These have 8. Everyone else wants to gain enough to be like the noble gases. Okay, so nitrogen, how many will it gain? Well, how many does it have now? Nitrogen is in group 5, so it has 5. So to get to 8, it will need to gain 3. Okay, how many will chlorine gain? So let's find chlorine. Look at the top, 7. So it has 7 electrons. It's going to gain 1 to make 8 because it has 7. Okay, so here it says if it loses electrons, it becomes positive. You really need to understand that because electrons are negative. So if it loses negative electrons, it becomes positive. Just like when you lose your negativity, you have a more positive attitude. If it gains electrons, it will have a negative charge. Okay, so let's take oxygen. Oxygen's a nonmetal. Here's oxygen. It's to the right of the stair step. It is definitely a nonmetal. It is going to gain. It has 6, and so it's going to gain 2 to make 8. That 8 valence electrons, the magic number, you just have to memorize it. Okay, the charge will be -2, and the symbol is written with a little -2 up to in the top right-hand corner. Okay, let's go to the reverse page. Find bromine. Okay, bromine. It is in group 7. And so it has 7, it will gain 1 to make 8, and it will become negative, and it will become -1. Our symbol is going to be written with a little -1 up to the top right-hand corner. That indicates that it's an ion. This is an ion, not atom anymore. An atom is just Br. Ion is when you put a charge on it. Doesn't matter if it's negative or positive. Okay, let's try calcium. Okay, calcium is over here. Calcium has 2 valence electrons. It will lose those because it is a metal. Loses them and becomes 2 positive. Now, why? Because electrons are negative. Okay, so which one do not like to gain? They don't like to lose or gain. These are going to be the group 8, the noble gases. They have 8 valence electrons, except this one. It's so small it only has 2, but it still has a complete outer energy level. Okay, and then elements tend to get larger. The size, of course, they get larger as they go down. This has 9, this has 17. So large as you go down, but going across, it doesn't make a lot of sense, but it does if you look at the nuclear charge. So they get larger to the left. So whatever's left is larger, these are smaller. And it's because the electrons are on the same energy level, but the protons get more and more and more protons, and so these get smaller because they get sucked in a little tighter to the nucleus. Okay, which is larger, potassium or cesium? Here's potassium, here's cesium. Which one's farther down? Cesium. Okay, oxygen and selenium. Oxygen, selenium. Selenium is larger. Okay, and again, let's say that I had nitrogen and fluorine. Okay, which one is farther left? That would be the larger one. So left larger. Nitrogen would be larger than fluorine. Okay, ions have either gained or lost electrons, and so they have a charge. Aluminum. Aluminum has 3 valence electrons. It's in 3A, and so it becomes aluminum ion. Okay, negative ions, well, they become a little larger, and positive ions become a lot smaller. And that's because you're gaining electrons to existing energy levels. The positive ones you're losing on an entire energy level, so make sure you know those. Which one will be larger? Well, the larger one, remember positive ions are smaller. This one's smaller, that has to be larger. Okay, again, here, negative ions tend to be a little larger. So this one's larger. It asks you smaller, this one. And these, I will let you all figure those out on your own. So you look up Al, find Al, and then write the word aluminum. Okay, I hope this helps. See you next time.